So in this lesson, we're going to take the concept of Lewis dot structures, and we're going to actually see the shape that is formed for these molecular compounds. So right here, if you look, I'm just going to go through this and explain it. If you have two electron groups, so that means either bonding electrons, so shared electrons, or lone electrons, if you've got two groups, then the shape is going to be linear. Okay? And so if you look at this example, if it's linear, then the angle, the bond angle, is going to be 180 degrees. Okay? If you have three electron groups, just three, okay, then it's going to be, the electron group geometry is going to be trigonal planar. Okay? Now notice that the shape is also trigonal planar, which begs the question, when would it not be the same, the electron group geometry and the shape? Let's look at an example. The next one, you've got three electron groups. It's trigonal planar for the electron geometry, but notice you've got two bonding and one lone. If you look at SO2, you've got two bonding, so you've got two atoms that are sharing electrons, and then what isn't represented is you've actually got two lone electrons on top. So if you've got two bonding, one lone, then the shape is going to be bent. So while the electron geometry is still trigonal planar because you've got three electron groups, two bonding, one lone, the shape is going to be bent. For the next one, if you've got four electron groups, the electron group geometry is going to be tetrahedral. If all four of those are bonding, then the shape is also going to be tetrahedral. So that's an example like for CH4. If you've got four electron groups, but three are bonding and one is lone, like for example in NH3, you can see you've got three atoms that are sharing electrons, and then there's going to be one lone group on top of that nitrogen there. So three bonding, one lone, then the shape is going to be different from the electron group geometry. The shape is going to be trigonal pyramidal because it looks like a pyramid. Then if you've got four electron groups, but two of them are bonding and two of them are lone, then your shape is going to be bent, just like water. Because for water, you've got two pairs of shared electrons, two bonds, and then you got two pairs of lone electrons. So those are the only shapes that for this class you are going to be responsible for. So let's try an example. So here I've given you PBr3. Okay? I've got to first count my total number of valence electrons. So I've got 5 from phosphorus, 7 from bromine, but they're 3 bromines, so that'd be a total of 26 valence electrons. Okay? Now I'm going to share electrons. So I'm going to draw lines in between these guys, and then I'm going to make sure all of my atoms have 8 valence electrons. So I'm going to start with my outer elements. So bromine needs 8. Right now each bromine only has 2, so I've got to add my lone pairs. Notice I drew a line instead of the 2 dots. If you want to draw a line instead of 2 dots, that's fine. It just saves a little bit of time. That's how I draw mine. Okay, and then phosphorus right now has 6. It needs 8, so I'm going to add 2 there. And so I'm done there. Now if you notice, I've got 1, 2, 3 bonding pairs, because I've got 3 bonds there, and then I've got 1 lone pair. So I've got a total of 4 electron groups, which means the shape of the electron group geometry is going to be tetrahedral. But notice I've got 3 bonding and 1 lone. So the shape of this molecule is not going to be tetrahedral. What you actually are going to see is trigonal pyramidal.